Hello, everybody. How are we all doing? Good afternoon. This will be the last stream for COMP1511. And this doesn't have a lot of structure or anything like that. It is something where I can definitely do Q&A stuff, but I also have some stuff here that I prepared earlier in a very, very funny way, because the two of the student societies, Women in Tech and CSE SOC, were hosting a kind of a study session for 1511, and it was actually pretty big by the looks of it. There was like, I don't know, I want to say like 100 people in person and 100 people online, something like that. So it was actually like much more of the course than I expected. So it was good. And what we ended up doing there for fun was we actually built an exam in person right then and there. We didn't flesh it out or anything. It obviously takes longer than that. But we put together the concepts for a bunch of questions. So if people haven't seen it, it went up on... This particular document went up on the CSE SOC Discord, because I just typed it up on the computer there in Word, just because that's what I had available, and I didn't actually download it myself or anything like that, but they did, and they posted it to Discord, so I grabbed it again. So we could have a look at these questions, but I think what could even be more interesting, because what I didn't do in that study session, in case people are doubling up, was go through and implement any of these. So what I could do is I could actually take one or two of these things all the way through to code. Obviously there's no auto tests, so it wouldn't be the kind of thing that you could actually necessarily go through the whole process of answering exam questions, but like we can go through a lot of it and talk about it. Otherwise, this stream is highly unstructured. It is basically any questions you have, ask me the questions and I'll take time to answer. And so if there's anything that you're studying and you're like, look, I've gone over the lecture material, I've gone over the tutorials as well and stuff, and I've hit a point where I don't fully understand what's going on. I really kind of could use a bit more information here to get what's happening. If you've got anything like that, feel free, and I can go over it again. I can attempt to teach something in a completely different way than the previous times I've taught it, which will hopefully give a different perspective on things if people have any questions like that. So just basically, if you want to, in chat, when I'm pointing over here at chat, I don't know if that's where your chat is, but actually I think on YouTube it is kind of, it's on the left, so it sort of works. But if you have any questions, just ask. In the meantime, I might... Let's have a look at some of these questions. So I don't know if people were in the study session already on Tuesday. So if you were in the study session on Tuesday, then you would have seen some of these things. So these are like the sample questions. And we were looking at the different kind of possibilities for these questions, and I don't know if they recorded that. I have a feeling that they probably wouldn't have recorded that, because they were trying to do it in many different ways. There was like a Zoom call, so that there was a camera on me, and then the audio was being shared over Discord, in more than one session on Discord. So it was like just trying to tie together a bunch of different kind of conferencing softwares and stuff. So I don't think there'll be one particular stream that is recorded that is definitely working. Okay, so Vishak is saying, please explain insert node in the beginning, middle, and end. Okay, so we'll definitely have a look at that. We'll definitely have a look at linked lists and look at the different cases for insertion of linked lists. So I can probably do that via a diagram. I don't know if we'll go too deep into code, but actually the code for insertion, it's a short amount of code that takes a lot of thinking. So there's a good chance I could actually write all that code for you. William is asking, is this course a double pass? I'm going to assume, but I don't know for certain, I'm going to assume the answer to that is no, because I'm not sure what a double pass is. But if you explain what a double pass is, then it might actually be. So I have my ways of knowing what is in the course and stuff like that, but I don't know if that's what the technical term a double pass is. So if you can explain, William, what you mean by a double pass, I might be able to let you know. Oh, right. Evan is saying the idea that you need to pass the exam as well as pass the course overall. It's not exactly. It is more what Evan's getting towards, where Evan's saying we have the hurdles. So what we have is the overall pass for the course, which is you have to get more than 50% over the entire course. If anyone is like kind of borderline, like really, really close to 50, then it's more likely that you're going to get higher marks in stuff like labs, and you're probably potentially also going to get full marks in reflections and stuff like that. So even if you don't get more than 50% of the exam, there's still a chance that you will pass the course. And also note that the hurdles in the exam are only worth 20% of the total exam. So if you got a mark of like 20 out of 100 in the exam and that was passing the hurdles, you still have an outside chance of passing the course. Like, you have to get pretty high marks elsewhere in the course, but you could still do it, right? So the passing the exam is not required. But when we say which parts of the exam are definitely required to pass the course, it's the bits where we've actually picked the content and we said these are the things you must be able to do if you want to follow on to the courses as a prerequisite for. So the only conditions for passing the course are greater than 50 out of 100 for all of the course assessment put together. So that is labs, reflections, 2 assignments, and the exam. You add all that up, and if it's greater than it's 50 or greater, then you pass. Well, you pass the course except for the hurdles. The hurdles are the 2 easiest. Well, there's actually 4 in a sense, but you only have to pass 1 arrays question and 1 linked list question in the exam, and you can do that with the easiest ones, question 1 and 2. And if something goes weirdly wrong with questions 1 and 2, we will also check questions 3 and 4. Basically, that's how that works. So what we say is if you have the basic capability in arrays and linked lists, and it's very hard to get close to a passing mark without that capability. If you've only got the capability to answer questions 1 and 2 in the exam, then that's okay, but I think you'll be it's around the same difficulty as the stage 1s in both of the assignments. So think about that. If stage 1 was a struggle but it was possible, then this is probably going to be the same level of struggle but possible in the exam. So that's where we're pitching at. And I think like the thing that you'll see is like the next subjects are going to assume that you can do that, and then they'll keep going on from there. So that's why we need to make sure that capability and that thought is really kind of solid in your mind to go on with. William was asking 1, 2, 3, and 4, or 1 and 3, or 2 and 4. It's like you have to get 1 of 1 and 3 and 1 of 2 and 4. Basically, questions 1 and 3 are array questions, and questions 2 and 4 are linked list questions, and you have to get 1 array question right and 1 linked list question right. Tawaka's saying, wait, are the hurdles worth 20% on their own? Well, they're worth 20% of the exam on their own, which is not 20% of the whole course. And Vishok was like, what if we don't answer any questions other than the hurdles? If you don't answer any questions other than the hurdles and you've gotten like 100% in all the rest of the course, you're still going to pass. So if you, well, You have to, if you pass the 2 hurdles, and don't answer anything else in the exam, your exam mark is going to be really, really low. But if your assignment's good enough, they'll probably get you over the line. Because the assignments can get you, if you got 100% in both assignments, I mean, look, if you got 100% in both assignments, I'm expecting you to at least get through to like question 5. I would say, like if someone's capable of doing all the hard stuff in the assignments and 100%ing them, then I would expect that they're going to get probably question 6 as well completed. I never offer any promises about question 7 and 8 because they're pretty hard. NK Pro was asking, are you saying that we have to pass the hurdles or attempt the hurdles? You have to pass the hurdles to pass the course. Because the hurdles are what I would say is the assumed knowledge in the next course. There's not one next course, there's multiple next courses. But if you don't have that assumed knowledge, you go into the next courses, it's like, you just end up in a lot of trouble, in a sense. Tom's written an actual code expression there, which shows it, which is quite funny. Zihanye is saying assignment 2 hasn't been marked. Yes, assignment 2 definitely hasn't been marked. It's only just been submitted, and not all of it has been submitted yet, because a lot of people have extensions and things like that. So we can't actually, because the assignment 2, especially after the revised deadline for a significant percentage of the course, was due on Monday. There's no way we can turn around the marking before the exam. I mean, just the way it was scheduled anyway is the police are angry with me for not marking assignment 2 yet. With the exam being, like, 5 days after the assignment deadline, there was no way we were ever going to get assignment 2 marked before the exam. So yes, you are going to end up getting your assignment and exam marks together at the end. But I think that the labs and the reflections are getting wrapped up soon, though. And William was asking about overall marks. We're not going to give you back your overall marks until we have stuff to add up. But you can actually add up all of your marks up until then. The components aren't scaled. They've already been scaled by us saying how much of each is each, you know. So pretty soon, in the next couple of days, you should be able to know what your lab and reflection marks are looking like. Remember, there is the late penalty for labs, which means any labs you submit after their due date are still worth 3/4, 75% of what they're worth, right up until the day before the exam. So, tomorrow. It's like forgetting how tight the timeline is and how things are moving along. Most everything is already marked, though, as Evan is saying there. Vishak, if you want to know details about the exam, go check out lecture number 17, where I went over everything in detail. Each of the questions in the exam, each of the practical questions in the exam are worth 10 marks each. Yeah, so as Evan's saying there, for some people, this isn't going to be everyone, because, you know, like, we run the automated systems and we check everything afterwards and stuff like that, everything except for the final reflection, the final lab, have been marked, which is good. Kevin's also saying, can we also still get 0.75 for lab challenges? Yes. You can get, like, any lab stuff that you want to do now, which is not bad, you know, like, doing the lab stuff now, if you're doing it now for study, and you hadn't already got a mark for it before, so maybe you missed a lab because you were sick or something, or you were just really, really busy with other subjects, and so you didn't attend a lab 1 week, you can hand stuff in now, and it may or may not make a difference to your mark, because we still only mark the best 7 out of 8 of your labs. So if you've already got full marks in lab, it's not really going to make a difference, but you can submit it if you want to. But if you're missing lab marks, you could still get 3/4 of them now by submitting the stuff you've been doing for study. You can tell what I'm doing there, right? You can tell that I'm just saying that I think that very, very good study for the exam is doing the labs you haven't done, because if you haven't done them, then there's definitely gaps in your knowledge there. So that was my little way of trying to create some incentive for people to still do them. So just say, like, you know, if you're studying and you missed content previously, how about I dangle this carrot in front of you? How about I give you some marks for it? You know, and so hopefully people are going to use that. NK Pro is saying, why do you think there is no auto test in the exam, NK Pro? There are auto tests in the exam. So anyone who's asking questions about the details of the exam, please go and watch lecture 17, where I spent an hour and a half talking about what's in the exam. There's so much detail in there. So yes, there are auto tests in the exam. And you can use the auto tests in the exam to check whether there's anything missing in your questions or anything like that. So there are, I think, yeah, I shouldn't say anything else, but like, go back and have a quick look at the lecture about the exam if you want to. And Tom's saying the forum is still active, even though help sessions have finished for the term, because the help sessions are really focused on assignment deadlines. And there's no tutes, so there's nothing more that you can ask your tutors. But other than that, you can still ask questions on the forum right up until the day of the exam. The forum will be paused during the exam. Okay, so I think we've finished with a lot of the clarifications of marks and assessment questions. If you do need, if you do really want to look over the details, some of the details are in the course outline. So details about hurdles, details about exactly how much marks everything that you've been marked for is worth. If you want to look up details for exactly what's in the exam and how the marks distribution is in the exam, then lecture number 17, which is the second last official lecture. It's funny how much content I've done after the lectures are finished, actually. But yeah, the second last official lecture, which is the Wednesday lecture of week 10, which is numbered lecture 17, is the one where the majority of the lecture, I think 1.5 hours out of the 2 hours, is just going through exactly how the exam works. So that's something that will probably be useful for everyone. Okay, so let us have a look at, I think maybe we'll do some code. So I had a request for looking at the beginning, middle, and end of linked lists. So I think that's an interesting one. Let's have a look at that. I will do it in pictures, and then I will do a little bit of code. And then after that, we might, because I think these are the important bits, we might actually solve practical questions 1 and 2 from this made-up sample exam that Tom and I made up in the study session on Tuesday. I was about to say yesterday, but obviously Wednesday just disappeared for me. But okay, so let's actually, I won't do it in here. I will was it insertion? I think it was insertion. William's asking if I will post that document online. I might post that document alongside today's where I would usually put the slides for today. Today obviously doesn't have slides, it's not a prepared day. So I might post it there, so that way for the next day and a half you've got some sample questions that you could use that are, well, they're not past exam questions, but I could say that they're questions that were written under the same motivation as the questions that we would write in the exam. If you're on CSCSOC, their Discord, it was posted on their Discord. I'm not going to open Discord right now. Just end up chatting with heaps of people instead. Okay, so here we have our linked list. And we were looking at insertion into the beginning of the list, somewhere in the middle, and at the end of the list. So insertion at the beginning is hang on, I'm going to color the head pointer green, and red is null. So if we're going to insert something at the beginning of the list, we're going to be creating a node, and then we're going to be attaching that node to the beginning of the list. So what happens is this has to become the new start of the list, and it will attach to what used to be the first element of the list, now has become the second element of the list, and the rest of the list we don't have to deal with. Like, we don't have any kind of work or anything to do over the rest of the list, because we're adding to the start of the list only. The thing that then needs to change is the pointer that points at the beginning of the list. So the head pointer now has to point at the new element, which is the beginning of the list. So what we would do is we would say, okay, the head pointer is no longer pointing at that element, because that element is now the second element. It is now pointing at this element. So what we would do is we would say, we're going to have a function that adds to a linked list, and what it's going to do is, if it's adding to the start of the linked list, it's going to have to be careful to return the new head of the list instead of returning the old head of the list. So the subtlety for adding at the start of the linked list is that the pointer to the whole list changes if we change what is at the beginning of the list. Just checking some other questions. There was a self-test question. Camille's asking about a list split question. I'll look up what that question is in a second. So it looks like a lot of people's questions are about linked list stuff, which I think is totally fine, because I have a feeling that by now, because it's sunk in by now, that everyone's got a pretty decent idea of what happened in the first half of the course, but the second half of the course is a bit harder. Okay, so that was inserting at the beginning of the list. If I want to insert something in the middle of the list, so I'm going to take another node here, and I'm going to insert it between these two elements here. So if I want to insert it between those two elements, it needs to join up to these, and we need to modify these pointers in such a way that this works. So the first thing that we're going to do is we're going to say, after we've created this, we want to say this thing's next pointer becomes the same as this thing's next pointer. So we're going to copy this element's next pointer. I'm going to name these so I can make this easier for myself. And this is going to be number 1, first insertion. This one will be the second insertion, and we'll have a third one over here in a second. Wait. Kevin had a question there saying, did you get a chance to look at my question? Disconnected for a little bit. Kevin's question was the 0.75 question. Yes. Wait, no, there was another. Can you explain when we should use each wave initializing strings and arrays in general? I will look at that in a second, Kevin. I reckon I'll go through this linked list stuff, and then we'll put that on the list of things that we want to talk about. These initializing arrays. I'm pretty sure that's the question that you're asking about. We'll get to it. Okay, so when I want to insert 2 in between B and C here, what I'm going to need to do is say that 2 needs to connect to C, and the only way to connect to C is the pointer that B has. So 2 is going to copy B's next pointer, which is this one here, and a copy of that pointer means it's aimed at the same place. So basically this is going to be a copy of this pointer. Then what we're going to need to do is say, and this has to happen in this order, because we copied B's next pointer. We don't want B to point at C. We now want B to point at 2. So if we don't want to point at C, we have to say your next pointer should not point at C. So we're going to overwrite its next pointer. Instead of B pointing at C, it should point at 2. So it's going to say, we're going to take the address of 2. We've just created it, so we know its address. And we put its address into B's next pointer, and it ends up like this. So in order to insert here, we'll create this, and then we'll create this pointer pointed at C using what B used to have. B used to point at C, so 2 copied B's pointer, and then after that 2 is going to replace B's next pointer with one that aims at 2 instead. And so that's the insertion in the middle of the list. Then we will do another color. an insertion at the end of the list. And the insertion at the end of the list is going to just get created as it is. Its next pointer, because we know it's going to be at the end of the list, if we've already decided in advance it's going to be at the end of the list, its next pointer is going to be pointing at null. But for it to now be attached to this list, this is actually getting interestingly complicated list, but it's all still a linked list, right? The head pointer points at one of them, and then it goes through, and all of these point at the next one until null. But we don't want C to point at null anymore. C is no longer the end of the list. We want 3 to be the end of the list. So if we've just created 3, then we know what the address of 3 is, which means we can create a pointer to 3 by putting that address into the pointer. So C has a next pointer, and the next pointer was null, but we're going to replace that null pointer with a pointer to 3. And so C's next pointer points at 3. It's no longer pointing at null. Alright. So, theoretically, and in pictures, diagrams, we now have seen the techniques that we would use to insert into linked lists either at the beginning, the middle, or the end. This isn't all the detail that we would need to make this thing work, but it's some of that detail. I'm wondering if what I should do is use some of the code that I've used previously. Where would insertion be is the second linked list lecture, which is 13. It's a battle royale at least. Let's see if this is the right code. Insert after? Okay, I've got my insert after here. So this is some of the code. I'm not sure if I want to write the code again. So this is actually all the code. So if we're inserting into an... Oh, not quite. This is into an empty list. Probably better if I start this fresh, but I'm going to keep this open anyway. Alright. I'm going to make a new directory. I'll call it linklist.c. Okay, so in order to make a linked list, I don't think we're going to do all of this code because I do want to answer more than one question today. I could definitely spend an hour and a half just on linked lists. What are we? Well, we're still in April, only just. Okay, so we're going to need potentially input, output. I actually don't even know if we are going to need that. Only if we're going to be printing stuff out. I'm going to assume that I'm going to be doing some memory allocation as well. Not going to bother with command line arguments for the moment. I'm going to need a struct. Alright, I'm going to keep this super basic, right? I'm just going to store a number. You want something more complex, always, check your second assignments. Because there's going to be heaps of stuff in there where you had linked list nodes that were much bigger than something like an individual number. And then we've got a pointer. to next. All right, so basic linked list structure here. So I probably don't even need anything in my main just yet. What we're looking at is an insert function. So what's the insert function going to take? What it needs to begin with is it needs to know the list that it's inserting into. So that is a node pointer to the head of the list. It's also going to need to know what needs to be inserted. So if we do this, let's do this in a way where we actually create and insert it. So the node never existed before that. So we have just the information that's going to go into the list and the pointer to the list. It also needs to give us something back. As we saw here, the head pointer could change. So we might actually change where the start of the list is. So if it changes, we want to know. So that's the kind of thing we're going to want to be given back. So if we're going to ask for some information back about the head of the list, then we need to have an output which is able to tell us what the head of the list is. So insert is going to take a list and a number. It's going to create a node for that number and insert it into this list, and then it's going to give back the head of the list. I'm wondering, because we were looking at like beginning, middle, and end, I wonder if we want to actually split this up into 3 different functions. We can either split it up into 3 different functions or do one function that has to do it in 3 different ways. We could do this, where we take in some information about the position. Let's try it that way. I'm just making this up as I go. Usually, how we're doing the insertion would be based on what's the purpose of what we're doing. So sometimes it's like insert alphabetically, or sometimes it's like insert specifically at the beginning, middle, or end, or something like that. But if I do it this way, we could do it where insert a new item into a linked list. Return the new head of the... Oh, it's not necessarily new. I'm just going to say return the head of the list, which may have changed. This works in 3 different positions. I'm just going to do 3 different positions instead of like counting and actually doing the actual positions. 0 is insert at the beginning. 1 is insert. There is no middle because we're not measuring the middle. I'm trying to make this easy so we can just do it. It's okay. You know what I'm gonna do? I'm gonna insert as the second element, and then 2 is insert as the final element. And this is actually a question we could ask in the exam. If I wanted to, we could do this as just not really. It's not really an exam. Maybe a question 4. It's not enough. It's not enough going on for a question 6. There's also not quite a question 4 though. So, you know, anyway, still worth studying. Okay, so we've got 3 different modes that this thing is going to operate in. So we might just check for that. Not necessarily. We're always going to create the node. So, call this new node. Is a memory allocation of a size of struct node. So yeah, you've seen this before now. So if you've been following along with the lectures, you know that every call to malloc that we've done in this course so far has been exactly the same. You take a type and you go, there's the type. It's the same thing on either side. We want this much memory for it, and then we get given back a pointer to it, which we store in this. So this new node pointer is the thing that gives us access to the node that's been created. We're going to access the element in there for data, and we're going to make it data. It's okay here for these things to have the same name because this one's specifically the one inside that node, and this is the one that we've been given as input. A lot of the time I will try to name my variables differently, but since there's no context for these yet, like there's no kind of, this number represents anything, it's hard for me to name it differently, so I'm just going to leave it like that. So we set up the new node. Oh, one thing I should do, in case anyone wants to follow along, I'm going to copy this and put it in the YouTube chat. So everyone has a link to my live code now. Well, anyone who's watching YouTube chat. I will put this link in the lecture section as well when when we're finished later. Okay, so created the new node, and then I can insert in 3 different places. So insert at the beginning. So I've been given some information when I call the function about where I want to insert. So I said, if I'm inserting at the beginning of the list, then what I'm going to say is, let's go back to my picture. The new node that I created, its next pointer is going to point at what had been the first element of the list previously. So we can do that in code. My new node next points at what had been the start of the list. Points at the head. Oops, sorry, caps locked there. Yeah, so that is creating this blue pointer that points at the head here, and then I need to move the pointer, the head pointer, which used to be here, to here. So what I'm going to say is now head is equal to new node. So I'm copying this pointer, so we know it's a pointer because it was created as a struct node pointer. So I'm going to say that pointer is going to get copied into the head. So what I've done is I've created this pointer, so making A the second element of the list by saying 1 comes before it and points at A, and then moving that pointer to here by replacing whatever value was in head before with the address of the new node. In order to do this, I know that I am going to be returning the head, because I said I was going to give back the head of the list, which may have changed, and here the header list has changed, so eventually when we reach the end of the function, we're going to return the head of the list. The other insertions that aren't inserting at the beginning, they're not going to change where the head of the list is, so me returning the head is just going to give back the same head that I was told was the beginning of the list. So this is the insertion at the beginning. We've created the node, we've had its next pointer aiming at the first element of the list, and then we say now, after we've connected this thing up to the rest of the list, it becomes the first element of the list. So then we can say, what's one of the other options? Position 1. If position is 1, I'm just going to make my comments consistent. I'm going to put them inside because I don't have space to put, I can't put a comment above this else if, it'll look weird. I'm going to put it inside here. Insert as the new second element of the list. Now, usually if we were searching for a position in the list that we want to insert into, we would end up with a pointer to an element and say we are inserting after this element. There's other code for that. Again, previous linked list code that actual lecture, lecture 13 and lecture 14, have searching through lists. I think the insertion and removal ones, whether it's 12, 13, 14, either way, there's a whole trilogy there if you want to go back. If you have time, that's like 6 hours. It's like counting the number of hours left between now and Saturday. But anyway, if we're inserting somewhere, we would usually have a pointer to the node that we're inserting after. So we would find that pointer if we could, because that's the easiest way to do an insertion. So remember here, if we had B and we're inserting after B, what we do is the new node's next pointer is a copy of B's pointer. So at the moment, if I'm inserting the second head of the list, in the as the second element of the list, and the head is the first element of the list. So what I'm saying is I'm creating the new node's next pointer, because I mean it has been created, but it hasn't been initialized. So I didn't have a value, so we're giving it a value. I mean, we can't finish this without giving the next pointer a value in all possibilities, because at no point do we want to insert something in a linked list and have its next pointer have no information. Like, worst case scenario, we want it to be null, but otherwise we want it to get information in all of these. So we know that we've given it information in the first case. Now we're going to give it information in the next case. So what is the pointer that we're using? So if I'm inserting after the head, so this diagram's not exactly the same because I just used a simple example, but it is just the node that came before. It had a next pointer aiming here at this node. That's the one we want to copy. So if it's the second element of the list, it comes after the head. So we say that the head's next tells us which node's going to be after us in the list. So my next should point at what the head's next used to point at. And now we say, now that we've copied that, we don't need it anymore, and we want this one to no longer point here at this one, but to point at us instead. So we're going to replace its next pointer. So the head's next pointer is now going to become us. That's how we say, I've made this new thing and you need to point at me. I'll give you my address, you store my address, then you know that I'm your next. So the head's next is now equal to new node. And we know that this is fine because this is saying this is a pointer and this is a pointer, so we're going to copy the address from this one into this one. So it's interesting that we have all of this kind of thinking in the diagrams and stuff, and this is where most of the work happens because the code is actually very short. But the code itself, if you haven't thought about the diagram initially and you haven't planned it out, is much harder to understand if you just write the code without thinking about what your plan is. Okay, so this moves all those pointers around. So we've created this one and moved this one to here. That's all we need to do. So this one is now inserted into the list like that. The other option was I could have done this another way, actually. I won't now, but I could have found the insertion point by either saying it's the second node or loop through to the end and then passed a pointer in for the insertion point and then run this code. That would have saved me on doubling up on code there. But I think for clarity's sake, I'm still just going to separate these into 3 different things. So insert as the new final element of the list. So this is going to be interesting, because if we want to insert at the end, it means we have to find the end of the list. So this is the most complicated one. So first, in order to find the end of the list, we have to loop through the list. I can't just loop yet. I need something to loop with. So I'm going to make a new temporary pointer, and this is the one that's going to move through the list. I don't want to loop using the head pointer, because if I change the head pointer, this one shouldn't change the head pointer because it's inserting as the final element. So the head pointer should be the thing that gets returned. So I need a new pointer, and I'm going to use the current pointer. So this is something that we would do often where we say the current pointer starts pointing at the head, and we're going to move this along until it reaches the end of the list. So this loop is going to keep looping until the current is the end of the list. So each step through the while loop, the current pointer moves to the next element of the list, and this loop stops when the current goes off the end of the list and it's pointed at null. So if we're in this situation, we do need to figure out what the last node was before the list ended. So it's not just the current pointer, we're going to get a previous pointer as well. So we're going to start this one off as null, just because if we're at the start of the list, the previous can't exist. So we're going to say if the previous can't exist because we're off, the start of the list, then it won't have a value. But what it's going to do is the previous pointer is going to catch up with the current pointer as the current pointer moves on. So we're going to track 2 pointers through the list. We've done this before, right? And then the previous pointer is going to end up showing us the final, what used to be the final element of the list, and we're going to insert another final element of the list after that one. So the previous pointer is going to end up pointing at the last element of the list. So what we're going to do is we're going to move both of these pointers in the while loop. The previous pointer is going to move to where the current pointer is, and then the current pointer is going to move on to the next. So basically the previous pointer is going to follow the current pointer as it moves along. For example, got any colors left? I've used orange. So let's say the current pointer is here and the previous pointer is here. This is how it starts. And then, first time through the loop, the previous pointer becomes the current pointer, and the current pointer becomes current next. So the previous pointer becomes a current pointer, which means the previous pointer is going to copy the current pointer. I'm just going to get rid of all of that because it's not going to be pointing at null anymore. So to make something a copy of something else, it then aims at that. Then the current pointer moves on to current next. So current pointer is pointing at this, its next is pointing at A, so the current's going to move there. Next time this happens, the grey one moves to A, the pink one moves to B, and so they're going to move along as a pair like that. And when we get to the end here, eventually at the end, this current will become null. This is the stopping case of the loop. So the loop will stop here. So it will say if the current is null, then the loop does not continue any further. The last state of the loop is going to look like this here. So what we're going to have is the previous pointer pointing at the last node of the list. The current pointer is off the end of the list now, so it doesn't matter. But we can use the previous pointer to then insert something after the end of the list. So the old end of the list had been the C, so the previous would have been there in the previous iteration of this before we added the 3. But here, previous is pointing at the last element of the list, which means we can now do an insertion, which is actually the same thing as this, except not the head anymore. We're not inserting after the head, we're inserting after this previous pointer that we've found. So we can do that insertion. New node next is equal to previous is next. And then previous next, now that we've copied it, we're going to replace it with a pointer to the new node. Right. Everything's good. Everything's working, right? Not exactly. So there's a couple of issues here. what if the previous doesn't exist? If the previous is null, we have an issue here. So if we go through this list but it never runs because the current is null, because the list is empty, then we cannot access previous next because previous doesn't exist. So if previous doesn't exist, then we need to do things differently. Previous doesn't exist if the list was empty, because previous will never move off null if the current's already null. The loop will never run. So if the list was empty, then the interesting thing about if the list was empty, we're doing this. We're inserting it at the beginning. Because if the list was empty, inserting at the end or the beginning is the same insertion. So we can actually just copy this. So if the list was empty, we're going to do this. Inserting at the beginning. There's a lot of repetition of code here. I would probably write this differently if I wasn't trying to show you all the different cases and splitting everything up like that. So if the list was empty, we do this. Otherwise, if the list is not empty, then inserting at the end is going to be fine because there's already something there. We do actually have a problem here with this one. Because what if we're inserting as the new second element of the list, but there isn't a first element of the list? So if the list was empty, I mean, this kind of doesn't make sense. We can't insert as the second element if the list was already empty. I might just leave this one as an assumption. Assumes that the list has at least one element already. So if it didn't have a head, then we would not be able to say what is the next element. So long as it has one node though, even if the next is null, this works. So we can kind of work like this. So, checking, Jennifer's saying something there. Wouldn't it be better to have an entirely overarching empty list case? Since no matter which position you have, then inserting into the empty list gives the same one element list. That's actually not a bad idea. So, I mean, that would mean that we're assuming that inserting as the second element of the list into an empty list it still inserts it into the list. That's probably not a bad assumption to make. So we could totally do that. I'm not going to bother doing that here because we're nearly at the end of the first hour and people have other questions that wanted answering. So what we have covered though is the idea of what do we do when we're inserting at the beginning? What if we're inserting at some position? So we happen to be inserting after the head, but this pointer could be a pointer to any of the nodes in the list, as it was here. So we've inserted at the beginning, we've inserted at the second position, and we've inserted at the final position. If we wanted to make this more efficient and more readable, we would probably restructure this whole thing. But I was going kind of... This is a really good kind of look at the process, the sort of longer term process of programming. This is how I will do things if someone asks me, okay, can you do something? I'll just split it up into its cases and I'll do it. And then as I'm doing it, I'll be like, do you notice that this is the same as this? This is the same as this. Splitting these up on these options was not very efficient. What I should have done is I should have assessed these options and then pathed each one towards these eventualities which shouldn't have been repeated. So this should not have been repeated. Repetitive code is kind of nasty because what if we change the way we insert at the head of the list? I have to find both of these things. Whereas if I wrote this once and I said both of these paths through this reach the same point, that would be neater. So this is often what I'll do is when I first write code, I write it without thinking. I just do it so that it works. And then afterwards I go, oh, look at that. I can restructure this so that I don't have to do as much work. Or I can restructure this so the computer doesn't have to do as much work. or I can restructure this so that the next person that looks at my code doesn't have to do as much work, so all those kinds of things are good. So this is really interesting because this is something that I learned from writing and art and things like that. So I think it's quite good to always think about the fact that computing. Some people think of computing as a really, really technical thing. Like, there's this like awful stereotype that we're all just nerds and we're just like man, just nerd kind of thing. But it's not true at all, because computing is a creative problem-solving pursuit, which means it requires a significant amount of creativity to do it well. What I did was I did this the same way that I would do an art piece. Like, I do a lot of painting, so like I do the same kind of thing where I just go, yes, I want these things here, and so I paint the colors where I want the colors. But what I do is I don't think too much about what I'm doing when I'm doing that. I just put the paint on. Well, I paint models. Other people paint canvases. I just put it on where it feels right, and then afterwards I look at it and I step back from it and I go, oh, if I want the light to shine from this direction, then I need to change the way I'm doing the colors in this particular way. And I'll go back and I'll refine it. The best thing that you can do when you're trying to be creative about things is to not try to pick at what you're doing when you're initially creating it. You just get it out there and make it happen. And then you look at it, you step back for a moment, you look at it and go, oh, I could make this better in different ways. That's a very good thing for programming, because what you kind of do is you go, I will do my initial solution to this problem, and I will try my initial solution on my instinct, and then I will refine that solution as I go on. So what we're actually using when we're programming is the artistic creative process. And I think that's that's one of the most beautiful things about programming, is like it's intense artistic creativity wrapped up in this idea that it isn't. So a lot of people get the idea that computing is like a purely technical exercise, but without the creativity and imagination of the human mind, it's very hard to write effective solutions to difficult problems. So it's kind of cool. It's a lovely combination. And Jennifer's also saying that we could get away with just using one pointer for finding the last node in the list. We wouldn't have to have dragged the current and the previous around, I think what you're saying. Yeah. So there's lots of different ways around this. And I think that's lovely, because I think what you're reaching there is the idea that we're not programmers, we're problem solvers. And we're going to use code in the solution to the problem, but the solving of the problem involves playing around with it in different ways and doing interesting things. All right. 2:58. This is a good time, especially because I've just completed this bit of code here. I'm not going to do the second iteration of this unless I run out of questions in the second half and there's nothing else to talk about. Maybe I'll come back, but I doubt it. So we're going to take a break now. It's 2:59 now by my clock, so we'll come back at 3:04 and we'll continue. I'll answer some of the other questions. I remember that Kevin had a question to go back to there, and someone else asked something, but we'll go back. I'll go back and look at the questions and answer them. All right, back soon. All right, we're back. Oh, I just went on break, came back, and I forgot to fill up my water. Give me a sec. I'll be back again. It's a weird thing. It's a weird thing doing this kind of, I don't know. Well, I guess you would call it public speaking. That's literally what public speaking is, being a lecturer. But you don't realize that, like, for me, it's like for every hour of public speaking, I drink a whole cup of water, and that's way more water than I would drink normally. But otherwise, my throat doesn't really like it. Doesn't like talking that much. And we noticed this, remember? This is the funniest thing when Tom took the guest lecture. And I'd forgot to remind him that one of the things that you kind of need to have is the glass of water. And it was around the 1 hour mark where he started coughing, and I was like, oh no, I know exactly what this point is. This is the point that I get to if I don't drink water to, like, keep the throat, I don't know, like, lubricated while you're talking and stuff. So it was really funny when that was happening. It was like, oh, I've thrown one of my tutors in the deep end, and I haven't like, the simplest piece of advice I could have given them, I forgot to give. Okay, so other questions we had. So Kevin had a question back here. Can you explain when we should use each way of initializing strings and arrays in general, i.e., creating a big array versus a malloc versus a string declaration of an array? So let's create a new. I'll call it arrays because excuse me. Because there's going to be a few different arrays here. And there's also many different ways we can initialize arrays, so it is quite interesting. Oops. I realized that last piece of code that I wrote, the linked list one, I didn't actually use standard input-output rule. Actually, I didn't even compile it. Didn't even bother to compile it. I was like, yes, this is the technique for the code. Let's compile it and see if it actually compiles. Okay, at least it compiled. We know it's syntactically correct. You can always test it later and see if it actually worked or not. You'd have to write another function that prints out the list and then test the insertion at different levels. I mean, this is all the stuff that I would do if I was actually demoing the code to you from a theoretical perspective of teaching you how to do this. But I've done that already in the lectures. I think this is enough to go over what... who was it? Was it Vishak was asking that, I think? Where was it? It was like ages ago. It was like a really early question before we even started talking about marks, I think. Let me just make sure. I don't know where the question is anymore. I actually can't find the question. Anyway, I think it was you, Vishak, but if it wasn't, that's fine. As long as someone asked it. I'm sure someone did ask it. Okay. Okay, so initialization of arrays. So, oops. I was just going to say, we're going to define a max length, but I didn't give it a number. Let's give it a computing number, 1024. So there's a few different ways I can define an array. If I want to, I can say let's say, start off with an array of integers. Integer array, let's call it numbers. And what I could do is I could say this thing has 10 in it. And you were asking about initializing based on different different initial values. So I've shown you this before, which is the empty set of curly brackets. Now, there's actually subtlety here. There is a subtle rule for what this does. I'm gonna actually type it out clearly, because I didn't ever bother going into this, because I thought this was something that, like, if people want to look up, they can find out about and stuff like that. If people want to go into the details, you can. You're also probably going to learn about this in a later course anyway, so you know, you're going to get this idea now from 1511, is that it is an introduction to programming. Which means it does not give you all the details. So I glossed over the details here. Like I glossed over the details for, like, the memory structure of a computer. And I glossed over the details for, like, abstraction and data types. What else did I gloss over the details? I mean, like, I've glossed over the details even for looping. I said we're only going to work with one kind of loop in this course, and, like, the other kinds, yeah, you can learn about them later if you want to, you know. So everything in this course is just the first piece of lots of different puzzles that you can then go deeper into. So this is one of them. Any initialization that doesn't completely fill the array will fill the remainder of the array with zeros. So, interesting things that we could do. This is another way we could do it. We go, okay, this thing's going to have the numbers 1 to 10. I should do this 0 to 9. I started counting like a normal human instead of a computer scientist. So 0 to 9. I can do another one. This will be the first one where people will be like, wait, what actually happens here? Right. This one is because I told you that this would fill it out with zeros, and I just told you that to make it easier. This one will fill it out with the exact numbers, because there's a precise number of inputs to match the number of spaces in the array. This one doesn't, it only has these. And so what it's going to do is it's going to put 0, 1, 2, and 3 in, and then all the rest are going to get given 0. This is particularly useful when we do this with character arrays, because the 0 is the null terminator. So if we don't fill something up, it's going to fill out all the rest of it with the null terminator. So there is a benefit to the null terminator actually having an ASCII value of 0. It doesn't have an ASCII value, it just has 0, right? Although, if I remember correctly, the ASCII value of 0 might actually be the null terminator. It might actually be specifically the null terminator. But let's look it up. What's one of these that I can scale up and people will be able to read? This one's got colors. Oops. I just had that zoomed in the right amount a second ago. There you go. 0 is null. So 0 is actually the null terminator. I mean, like, it's null, but we can use it as the null terminator. So if all of the rest of the items in here are 0 afterwards, that's going to work for strings as well as it is going to work for numbers. So when we've got this thing, we have a possible maximum length and we're not going to use all of it, then we can still do stuff with arrays. So actually, let's just get back to the question itself. Kevin's question. No, I've scrolled past it. when we use each way of initializing strings and arrays in general. Okay, so what we've got here is these bits and pieces. When we know exactly how many things we're going to do, okay, so why do we... So let's say I've got a max length there, but I also have define... That's exactly the same typo I made last time. I think it's a left and right hand thing where my right hand went faster than my left. Define... So we did this, right? 4 players in a game tracking their scores. So if I have a specific number of players, this makes a lot of sense. So I will hash define a number that is a unchangeable number. It will always be the specific quantity of things in the game, and during the play of this game, for example, the number of players doesn't change. So it's a 4-player game, it's always 4 players for the whole game. If there's any less than 4 players, the game ends, whatever, like that kind of thing. This means that I will always use all my arrays that deal with players in that game using this hash define, and we'll have this kind of safe knowledge of the number of players. So, example 1, when we have a specific and unchanging number of things, we use a hash define, and actually I won't say any more than that, that's enough. We use the hash define. And then we have another example when we aren't sure how big something will be. But we have to create an upper limit somewhere. So let me just so I can put this in the middle of the screen. I could do something different where so let's say, for example, I'm getting players to type in their name, and I don't know how long their name is going to be. So what I do is I say I will just declare an array of a certain size, and then I will do, say, an fgets into this. I think I just did fgets from memory. We'll see if I'm wrong in a second if I compile this. So you note that I didn't even initialize this with any values, because I'm assuming that this thing is going to write values into it. So I allowed this thing to be quite dangerous for the time in between these 2 lines. Because if I declare an array and I don't put anything into it, then I have no guarantee about what data is in there. If I wanted to be careful, I could do this and be like, all right, let's just zero out this thing. So if something goes weird and someone inserts some code in between these 2 lines and starts using the name, then at least the name will be empty, because it'll be full of null terminators at that point. So I could do that if I want to. So it's kind of like, how clean is my memory? So if I make this without initializing it, my memory is initially dirty, and I'm trusting this function to clean it. If I put this on the end, and I initialize it all as null terminators, and I'm going to say, okay, it's always clean. And then this thing is going to change it, but it's going to change it from something to clean to something else that's also clean, another string, because we trust fgets to do what it's supposed to do. So this is an example of me saying, I have a big array and I'm not necessarily using all of it, but I might, and I don't know, and I'm going to let the user tell me how much of it we're going to use. Right. Another example, this is a specific characters example, and I don't use these in 1511, but they do exist, and you could. We don't know how long something is, but it's a string that won't change during the running of the program. So I have specifically not really used these in 1511 because I didn't really want people to get into the habit of declaring variables with no length. However, it is technically possible. We can do this. So what this does is it says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus a null terminator 13. This thing will end up 13 long. It'll end up exactly long enough to fill this. So the interesting thing about that, though, is that every time we use this afterwards, we don't know how long it is. Like, if we wanted to find out how long it is, we'd have to do something like a strlen. We don't do strlen yet because we haven't got it. Now we have the string library, we'll be able to do strlen. So then we know the length. Otherwise, we literally don't know it because we don't have a number in here. These ones, we know in our program exactly how long these arrays are because we've set that up before we even created the arrays. We already knew how big they needed to be. This one's like, we don't know how big it needs to be. Just fill this thing. And if we come back and edit our code, we're going to change this, so we can't really have that as a hash define or anything, because what if we go, oh, look, we're just too happy, like, can we be a bit less happy? And then we go, oh, where is this changing? You know? And so doing it in this kind of method kind of works, because you go, okay, just create it based on the string that I need. And, like, you know, as we go through the development cycle, I may change the things I want to say to the user. So I'm going to keep editing this string, and so for me to know how long that is, I would probably have to do a strlen after it's created to see how long it is. The other thing I could do is I could never bother to find out how long it is, and all I would do is assume that there's a null terminator on the end, and say, okay, anything we ever wanted to do with this string, we would just only use string functions on it. And we would say, this thing is a string, only use string functions, never treat it as an array. And then, right, if you're up to date on the stuff I was talking about abstraction and stuff like that, I have turned this into an abstract concept of a string rather than an array of characters. You know, because I stopped thinking about it like an array of characters. I start thinking about it like this word or this line of text only gets used with the functions from the string library instead, or it only gets printed out as a whole. We never access individual letters of it. So it's interesting like that, because then we could nearly do something funny, like where we could type def wait I was about to hash type def. I've been doing too many different kinds of programming. Okay, so type def, let me say character pointer string, and then I can do this like nearly like an abstract data type, where I go, it's a capital S string. Don't think of it as a character pointer or as a character array. It is neither of those things. It is a capital S string, and the only things we're going to use it with is the functions in string.h. So if I want to do, I could do that kind of thing, and I could say here, actually not sure if this is 100% going to work. We'll see. I don't know if this needs to be a character pointer or a character array, or whether that will even make a difference. Interesting. I haven't tried this recently, but something like that. And then we start to think of this as an abstract concept instead. We'll find out if this is wrong when I compile it. I'm sort of just going off the like, oh, we could do this, we could do that. Tuaga was like, I was about to say he's behind you. Yeah, I'm not even sure. Camille was asking a good question here, like about these similar things. Can we return a character from a function like we return an int? Yes, you can. You can return a character even if you're supposed to return an int, because the character is an integer that fits within the range of integers. So because integers are like what, 2 billion, negative 2 billion to positive 2 billion kind of thing. And characters are like 0 to 255. So they're like, yeah, totally, we can just return a character as if it's an integer, and it works. Okay. I'm not sure if I should leave that. I'm not sure if this is going to work here. But we'll see. I'll compile it and see if it works. So, these are different ways that we can initialize. So, if we want to, we can initialize with specific values, or we can initialize with partial values and have the zeros fill out the rest. When we know exactly how many things are going to be in the program, in a sense, and they're going to be like that the whole way through, then we can go hash define. If we're not sure the maximum length that something can be, but we have a limitation, we're going to be like, look, we're not going to use 8 gigabytes of memory for every person's name, so we're going to cut this down. 1,000 characters should be more than people are identifying themselves by. So we should be able to do that. I say should, never going to be certain, but, we should be able to do that. And then we have here the weirder one, which is like, we do not specify how big our array is, and we specify it on the creation of the string that goes into it. But then we need to start thinking about these things as the potential concept of, this is not an array. It's just, you don't want to think of it like an array, because you don't really know how long it is. You have to keep checking for how long it is. And even this is deceptive, because this is not the length of the array. This is the number of letters before the null terminator. This still won't tell you how many elements are in this array. So there's still no way for us to know how many elements are in this array, only how many characters are before the null terminator. And if we were to edit this and put a null terminator like in here, this is a weird thing to do, by the way, but I think this is technically possible. This would render this into non-existence, in a sense. But if we were to put a null terminator in here, this length number would shorten. Even if there was memory somewhere that had been allocated to this on the creation of the array, we would never necessarily be able to access it. So these are weird arrays like that. So I didn't even bother going into that in the course. I thought that was like, there's enough information going out as it is. The course is so dense in certain parts of it. And I'm just like, okay, this detail, it's not necessary. You'll figure it out later. Like, it's not what you need to understand it. It's not something you can use later if you get more nuance with things. So yeah, this is a weird one. But hopefully, Kevin, that gives you some more information about the different ways that we can initialize arrays, and not necessarily me saying like this is exactly how you have to do things, but these two examples are pretty clear cut, so a big maximum if we don't know what the total size is going to be, but we want to be above it. We want people to feel like they have unlimited space, but we're judging based on the way that they're going to use it, how much space we're going to give them. And this one is like, this is really specific. There is this number of things and will always be this number of things. And then this one's like super weird, where it's like, just make it as big as it needs to be, and then we'll use it. So that's where we get into the idea that strings are not arrays. It's a weird thing to say, but they're arrays with a really specific condition, which allows us to change the length of them in our thinking without them physically having to change the array size. Because the array size doesn't change. I mean, this is a weird array because this array is allocated when it's created and initialized, in a sense. Like, so this gets memory based on how big this is. as opposed to other things where we go, okay, before we even start compiling, we know how much memory we're going to need for these things. The compiler has to hit this line, read how big this is, and go, okay, this is how much space this thing needs on the program stack. Stuvac is saying we can loop through a string like an array and have a counter variable to see how long it is, right? We could, but this is the same as any other array, where if you want to loop through, how do you know when you're at the end or not? Because the only way to find out you're at the end of the array is to access an element and to get an array out of bounds exception, which stops your entire program. The only thing you can look for is the null terminator. But let me show you. Okay, so we've got this hello, and it was made a certain size. And then what if I then did something like string copy into hello, the string hello, because I'm like, well, you said it was hello, right? And then we go stolen the integer lengths here and here are different. And once we've done this and we've shortened it by basically putting a null terminator partway through whatever allocated memory we had for that array, we will never know what's happening in the other side, because we never knew how big this was, because it doesn't have one of these that's really specifically telling us how big it is. Which is why these ones are actually quite dangerous to use, because once you start editing them, now let me try to edit it differently. String copy into hello. Hello there. I can't remember what it is. General Kenobi. Do people get this one? This is like it's a Clone Wars joke, but this is actually two different people saying. So I go, oh, I've got a string. I want to put all of this into it, and then I'm like, I run out of space because initially it wasn't created big enough to fit this much stuff in it, right? So there's weirdness there, where because I don't know what the maximum capacity of this thing is, because the maximum capacity was created here, I would have to use this, and now I've overwritten it and stuff. Like, now I'm trying to put more data into something than can be there. So it's weird, right? Oh, Camille's asking, what is that capital string thing? Like, what is this thing that Mark did? I did this as a possibility for abstraction. I don't know if it works. I have a feeling that it doesn't. Because it's I don't know if this is going to work here for a declaration of a string, but we'll see. Jennifer's asking if we're going to test it. I think we should. This is just one of those things where it's like, if I was doing this in another language, this would have worked differently, but I can't remember how C does this. I've used too many programming languages in my life to be able to remember exactly what each one does when I do something that is questionable like this. Is a char star, we call them char stars sometimes, the character array or the character pointer, is that going to be able to be initialized? Can I initialize a character pointer as a string? That's what I'm asking here. Let's compile this, because I've put a whole lot of mess in here now. And I also don't know what's going to happen here. Will it copy in just enough that it can fit, or will it throw an error when we try to copy this? I think it's time to print this thing out and see what it looks like. See, my little Clone Wars reference works there. Oh wait, it was called arrays, wasn't it? Oh no. No. Oh wait. It's just a semicolon. Although I think this still might not work. No, it still didn't work. let's see if I define it as an array specifically. I still don't think this is going to work. No. No. So the type def is weird, because the type def is saying this type is the same as this type, but trying to type define something as a non-specific length array, I think, is one thing that's not working here. Trying to do it as a pointer and then trying to initialize a pointer as an array was also something that wasn't really working there. So this was an idea, and I think it's an idea that doesn't work in C. Not sure though. If any of the tutors are still there, if you can like have a dig into this and see why that was or wasn't working, that would be interesting. Oh wait, no, this totally could work. I'm gonna go back. I realized what the problem was. I didn't give it a name. I was like trying to initialize a variable without a name. It's like this, like let's just go back to the very beginning of C, and the simplest thing I ever taught you, and I got that wrong. I think that's a beautiful thing, by the way. I think it's quite funny. It's like you got to remember that like no one in programming is free from mistakes. We will make lots of mistakes, including even the simplest mistakes, and it's all about kind of how we're going to recover from those mistakes and then fix things, rather than like you know, trying too hard to never make any mistakes tends to lead you towards never attempting anything interesting. Okay, not bad. Brackets not allowed here. To declare an array, place the brackets after the identifier. Nah, it's not letting me type def that array, so let me try to type def it as a pointer instead. I know I can type def pointers, because we've done that before. And if I can type def pointers, can I initialize that like so? I only have warnings now. So this is interesting. I was just saying I'm not using any of these variables, which is true. I created all these things and never used them. So if I run this, the only thing that's going to happen is a printf. Oh, it's going to be an fgets. And then printf. The fgets is never going to get used. So let's have a quick look. The fgets. Let me just type in hello. Oh, nope. Stack Overflow! Yay! We've created a website. We have gone over something in our stack. So our stack has an array in it, which is called hello. That also means that this thing did work. So that was able to be created. So if I wanted to abstract away the string, I could do this type def, and I could declare things with a capital S string, and then with those things I could just, like, for me, never use them as character arrays, but instead use them as things that get passed into string.h functions. But anyway, so we had our lengths, we were playing around with copying things in, and I'm pretty sure this line here, yes, is the problem. We have access past the end of a local variable. So string copy has read this and then tried to write it into this one, which only had this much space. And so when it went off the end, it tried to write letters off the end. There we have an issue. It doesn't actually... No, the copy never happened. So it still says hello world. It doesn't say hello there, General Kenobi. Anyway. So that's the issue, and that's the danger of these ones, is that we can know the length of the string that is currently stored in them, but we can't ever be sure of their capacity, and it's easy to make mistakes about their capacity, and there's no, like, this function's not able to check that for us. So little things like that are interesting. Jennifer picked up on it. You haven't named your string. That was like so simple, right? Okay, so Kevin was asking, when do we want to use malloc? That's an interesting thing. The times that I will use malloc is when we want to push the creation of something out. So we don't want it being created in our main. We want something like this. This is very, very silly what I'm doing here, this function, because it's like, it's a one-liner. I could have just done it in my code. So I receive a word and I want to create a string out of it, and it's deeply ironic because this is a string already. But if I want to do this and know how long it's going to be, then I can do this with a max length. So, actually I wouldn't even do this with a string. I would do this only in the case of having something like a struct. So, I'm going to change this. I'm going to change this to a linked list. Create string node. And before these, I'm going to have a struct. String node where I say this has a character array in it. It's got a line in it, which has max length. And then it has a string struct string node pointer next. Right. Create string node is going to give back string node pointer. When I'm creating something like this, this is when I would malloc, because what I've done is I've decided that the creation of this thing is going to happen in a separate function. If it's happening in a separate function, it means that the variable that's created here needs to last outside of this function. So instead of it being inside these curly brackets and only existing for that amount of time, I need to create it and give it back to the main function. So in that case, I would malloc. I say that this variable will then last longer than the curly brackets that it's within. I will rarely ever malloc a single variable like a string. I will usually malloc structs. So I will usually only be mallocing something if it has a larger context and it is a bigger thing. So it's very, very rare for me to do something like size of, actually don't even know if this works. Pretty sure it doesn't. That, as far as I know, is not going to go into size of. That's the weird thing about manual allocating arrays. The way that I think that I'm going to have to do this, let me just... I think that this is the way that I'm going to have to do it, where I go, what's the size of a character? It's going to be 1 byte, multiplied by how big is the array going to be, and I give you a pointer to the start of that memory, which is the beginning of the array. as opposed to, I have an array of this size, what is its size? I don't think that'll deal with that. I think we have to split it out like this and say, what is the size of an individual type? And that is a number that we can then multiply. I don't even know if this needs brackets. It might. So it might get a bit complicated. So another reason why I don't usually malloc these things is that they get fiddly. Whereas if they're all contained within one individual piece, I can malloc the whole lot. But the rules for malloc really is I will only memory allocate something if I'm going to build it separately in its own function, and I'm going to be passing around pointers to these things, which is basically structs. When structs get really, really big, you don't want to pass an actual struct into functions. You only want to pass pointers to structs. And this is not something you have to worry about too much in 1511, but in the future, this makes a big difference, because if you call a function with a gigantic struct, let's say I have a struct that's like 2 megabytes, like it's a big struct with all this data in it, and I call a function, it's going to copy that struct. So it's going to spend CPU cycles copying 2 megabytes of memory into another 2 megabytes of memory, putting that on the call stack and then running it. As opposed to, if I give a pointer to it, all I do is 64 bits and then I get going, right? I don't have to like slow down and do that copy. Don't worry too much about things running fast. We have not even touched on things running fast, but that's one of the reasons why in the future you will be using malloc and pointers to things. It's like, okay, we've got our memory, we've allocated our memory, and we just keep using that memory by throwing pointers to it, to different functions, rather than copying that whole block of memory around the place. So it's a little bit fiddly like that. Jennifer's also saying we could put the size in the type def. So I think the implication is that we could do something like this, I assume. How does that work? It doesn't look like legal C to me, because this doesn't have a name. 5 messages back. Let's go further back. Blah, blah, blah. Jennifer is right. He's behind you again. Stack Overflow devs should have done this. Type defing an array works. You have to make it type def character string. Oh, put this here, and it will go, this is the name of this type. And then we'll be able to do that. And then we can do whatchamacallit, then we can know exactly how long it is. We know its capacity then, not just its current length, which is what strlen can tell us, but its overall capacity. So we could do that. I'm going to put that in comments. So that's another option. Okay. Lots of different ways we could make this work. I'm going into probably more detail than is necessary, but hopefully, Kevin, what I've done here is I've shown you lots and lots of different ways that we could work with arrays. I'm gonna, in case people look at this later, hopefully people read the comments when I do this. It's more than an object. It's a variable. So, what was it? Ooh, I just saw that underscore. You can tell the difference between stuff that I've kind of rehearsed and prepared versus stuff that I'm just throwing in as we go. There's a lot more when I just throw it in as we go of just like, don't know if this works. I think it might. I would make an attempt with something and then I would explore further to see whether it works or not. And that's more kind of like real programming in a sense, where you do want to program as if you don't know what's going to happen, and then you test. to see things. And then, like, you know, the more programming you do, the more you kind of know what's going to happen. But also, like, you know, it's not something that you have to focus on or is 100% necessary to always know what's going to happen with your code before you run it. You have an intention for it, you have experiments with it, and then you say, okay, this is how this thing works. So why I teach you all that stuff about problem solving and testing and debugging and things like that, because that's actually more of what the real process is. I think sometimes that maybe I know the demos too well, and so maybe I need to make more mistakes in demos, more things like this where I'm saying I'm not sure how that works. We should compile it to see how that works, you know, because I think that would reflect the way that you're going to go through this more, rather than doing it was like, this is the 24th time I have taught this, so this is just how it works, you know. You need to think about that. Anyway, okay, so here I'm saying when I'm doing a malloc, what I will more often do is the malloc of a struct. And we've seen this before, because I've done this earlier today. Alright, brackets are correct. Yeah, something like that. Yeah, I don't think this code's going to compile anymore. I've just done a whole bunch of random stuff in it. Maybe. We'll see. We don't need it to compile anymore, I think, at the moment. Vishak is asking, can I describe about getchar, putchar, and fputs, fgets, and where we should use it? Right, I can do that. We've got 10 minutes left, so that'll be the last thing, I think. Let's create a new one. Input output .c. Okay. Well, it's not going to be a demo. Some info on different input output methods. Okay, this time we're actually going to be using it. Standard input output.h. So, a couple of different things that we can do. So, different situations. I want every single character that was input. How should I do this? Let's do a character array. Gonna call it an input buffer. I don't know, 1024. It's probably gonna need to be bigger than this, but I'm just gonna do that for the moment. Okay, so I've got a buffer for input. In char, so input character. Equals getchar. Pretty sure getchar is the thing that's going to return it, and so while the input character is not equal to end of input, end of file, they say, because sometimes you're reading from a file, not from input. We know in this case we're reading from input because we're using getchar. While it's not that, I'm going to need an I as well. input buffer I is equal to the input character that we got, then I goes up 1. Which means we're also going to want to say if another stopping case. So one is if we don't get any more input, and the other stopping case might be we're up to input size. I is the greater than or equal to... No. We keep going while I is less than input size. My muscle memory triggered that. It was quite funny. My muscle memory said, you never do greater than or equal to. What is going on here? It should be less than. So, while we still have input and it's less than input size, we read in a character into there and we store it in this buffer. The interesting thing about what we're going to get here, we will read all spaces, invisible characters, and new lines and store them all. This is why we would use getchar if we're using getchar, if we want every single character. Otherwise, if we only want a series of numbers and we're ignoring spaces in between, we also want numbers, not just digits. So we want something to just deal with this whole thing and make them numbers for us. Then we would do something differently where we'd say, okay, here's an integer array. I mean, this code should look pretty familiar. Input numbers. Let's use input size again. It's probably not... This is where like the hash define has a meaning and you shouldn't use the hash define for the meaning even though it's the same number. I'm going to change it. I'm going to have a new one. I know it's the same number, but sometimes hash defines are not about the number, but they're about the meaning. Max numbers. Okay, so we have this input, this array of numbers that we can have, and then we start off at 0, while I is less than max numbers. Scanf a number into... Actually, maybe max numbers shouldn't even be that long. Let's say we're getting 10 numbers. Scanf a number into the address of input numbers I, and then I++. So this is going to scan in 10 numbers. So the way that we're going to type these things in is going to be very different. This thing is not going to be able to identify numbers that are different digits. It's going to just, like, every character is just going to be a character. Whereas this thing is going to be very different, where we're going to use scanf instead of getchar in this case, and scanf is going to process those digits. And there's other things that we might want to do for different purposes. I want to store a bulk amount of input and process it later. This would be used possibly if we know that an entire command takes a line and will process it as a string in another function, maybe. So I can have an array again. What did I call it last time? Okay. It's not input buffer this time, but it will be the same thing, input size. And I go fgets. And I grab the whole line and I say put it into input, maximum size is input size, and it comes from standard in. So I would use this if I want a whole line, and I don't want to have to write code that scans multiple times and stuff like that. I don't want to just grab all the characters, because this thing's not going to stop when it hits a new line. It's just going to keep going when it hits a new line. It's only going to stop when we say there is no more input. So, in fact, these bits of code might not all work together in the same program. These are snippets that you would probably copy paste into other things. But this is going to grab the whole line, and then I might do the thing where I strip the new line off the end. So I go, gonna need the string library for this one. I don't know if I really need to do this code. I think this code's been shown before. I'll just type it in. It's not that hard. If input strlen of input, so this is the final element of input. If the final element of input is a new line, and often we would expect it to be a new line, then we're going to replace it. With a null terminator, which is going to say that that new line does no longer exist. We're cutting it off the word and saying the word ends one character earlier. So we can use this code to strip the new line off in fgets if we want. I do check for it. So I used to actually just do it like this. You just replace it. But we don't always know that the last letter is a new line, because sometimes we type in more things than the input size, and so we don't have a new line on the end. So if we have a new line on the end, we're going to replace it, and then we can just go on and use that data. So that's some examples of some of the different things we could use. Output similar to input, in that if I want to throw out individual characters one at a time, then I would do it with something like putchar. If I want to format things in a particular way, then I would use something like printf, because printf can take a character and print it out as a number or as an ASCII character. It can take a pointer and it can print out the address of the pointer, or you can dereference the pointer and then print it out as whatever thing it's going to be. So printf is quite powerful because it reformats your data and makes it look different, in a sense. Like, you can make it look like a different data type even than the one it's declared as. And then fputs is like, I've just got bulk characters and I just want to dump them to the screen one line at a time. So fputs and fgets is very much like saying we're no longer thinking about individual words or individual characters. So scanf and printf tend to think of individual words because they do things separated by spaces. Putchar and getchar think of individual characters, which means they do process all the spaces and the new lines and things. So they're going to use them as characters, whereas scanf is going to ignore them. Like, you can't get a scanf with a new line in it, because new line it treats as a gap in between words, and you can't scanf with a space either. So anytime there's a space, it goes, no, that's in between my symbols. Whereas if we want to say, I want an entire line, and the only separator between these things is the new lines, so I will take all the spaces as well. I will even take the new line, then I can do fgets. So they're used for different levels of focus on things. You're focusing on characters, focusing on words, or focusing on the entire line. That's when you use the different functions. Hopefully that's enough information to help you out with that. Lewis said, are we allowed to create our own C library and copy paste, or do we have to re-implement everything in the exam? I actually answered this question on Tuesday. Someone asked this question on Tuesday and said, can we pre-write our own libraries? And it's like, yeah, totally. If you're at that point, like, not many people are, but if you're at the point where you have already written your own C library, so I can do something like this. I don't have it with me. Also, mine's in C++ anyway. Ooh, that's That's the wrong one. The only downside to this that I have to say to you, Lewis, Lewis is asking, are we allowed to create our own C library and copy paste, or do we have to re-implement everything in the exam? I don't know if I already said that question. We can't do this in the exam because you can only submit one file per question. But if I have bits and pieces here that I've written in advance, yes, I can copy paste them. That's the point of an open book exam. We're not testing you on whether you can write it then and there. If you've written it before, you can use it. And similarly, and this is the way that people are going to be programming for the next little while, is you're going to keep going back to my source material, right? You're going to keep going back to my lecture slides and my lectures and using them. That's totally fine. That's part of it. So if you find that I've written an exam question so badly that you can copy paste the code from the lectures and answer the question with that, then that's my fault for writing the exam question badly. But most of the exam questions are written in such a way that you will have to at least know the concept to be able to do it. But if you've proven that you know the concept and you know that you've got code that you can either see, as in my code, or you've written yourself that you can edit for the purpose of the exam, then that's totally fine. That's part of it. I think the only difference is if you take the code from online or something like that, because we see that same stuff. You need to credit if you're using someone else's code. You know, if you're copy pasting a massive solution of Stack Overflow, and then we look at it and just go, that looks nothing like our code. It's full of, like, it's obviously not following our code style and other stuff like that. Then you probably want to say, look, it's where I got this from, right? Because what we do want to test is, like, yes, it's good for you to be able to look up stuff, but we do want to test your actual ability to do things. Zihan Ye said, can we use all the library in the exam? Yes. So you can use string.h, standard input output at h, and stuff like that. I think there was a limitation at one point in the assignment for using string.h. I think we ended up removing it, but like there was a thing where we wanted you to process some things yourself. But only in specific situations will we do that. When we're asking you to, like, when we're throwing the kitchen sink at you, when we're saying you have to do everything that we've taught you, then we taught you how to use libraries. So we want you to show that you can do that also. So we want you to know which libraries to include. Trick question, always include input output and standard lib if you're doing any memory allocation, then go on from there. Then you'll probably be fine. You will note that when we give you files that are pre-written, that have parts pre-written, they will probably have all the includes you need in them already. When you have to make the file yourself, you have to decide which things to include, and so that's an important skill, right? So you have to demonstrate that in the exam. NK Pro is saying, so the main long answer questions from 1 to 8, will the questions be like the ones like the revision, i.e. only have to create a function or a struct and not touch the main function? Or should we code them from scratch with the given questions? I got asked this on Tuesday as well, and I gave a funny answer. The answer to your question is yes. Because you gave me 2 options, and we will be giving you both of those options. So, some questions in the exam, we will give you nothing. So, you will have an empty file, and you'll be expected to write all your code from an empty file. Other questions in the exam, we will give you something that has, say, a main function and 1 or 2 other functions, and say, this function is empty, you have to implement this function. And so one of them is testing whether you can do all your setup properly, like set up a file from scratch, and the other one is testing whether, if someone else has written some code, can you read it and understand it and integrate what you can write into it. So we'll test both of those things. It's like, I can say that with a certainty that in questions 1 to 8, some of them will have some pre-written code, and some of them will have no pre-written code. Jennifer is asking, how accurate are the guidelines rules in the prac exam? Particularly for the line, you may not copy code from the internet, even with attribute... Oh, oops. I think that was... I think I might need to clarify that one. Because... like, what constitutes the internet at that point? Does that mean because my lecture slides and stuff is on the internet and I've said specifically that you can copy that stuff, then that breaks that rule. Because I said that you can copy from the code that I've taught you from without attribution. So, Jennifer, I'm going to have to look at those rules, because I have a feeling that those rules aren't quite correct, in that what I've been saying is that you can use whatever you can find. If you use a lot of stuff, you have to attribute it. So, yeah, and the line before, as he says, this means you can use any resources from the course or from online. So it's like, what am I saying? Am I saying that you can't copy code, or you can copy code so long as you type it in separately? But like, that doesn't really make any sense, right? So I think that where I'm going to lean on that is that you can use things that you can find, because you're going to, right? If it's an open book, the whole point of it is, if you think you have the time, you can go look stuff up. Look, technically, if you think you have the time, you could have not done anything in the course up to this point at all, and then hop into the exam and speed watch the lectures, and then do the questions based on speed watching the lectures. I think that there may be some people in the world capable of doing that, which would be kind of scary. But yeah, so you can use stuff from online, but if you copy paste a large amount of stuff from somewhere, then you do need to attribute it. I think it'll be more like that than like saying that you just can't use anything. Zihan's asking if you can use for. So if you want to use for loops, or you may have noticed that if you'd used for loops previously, the stuff still compiles and it still works and it passes auto tests and things. So we're not specifically forbidding the use of for loops, but we were definitely not teaching them, because it's much easier to understand while loops than for loops. So if you want to use them, you can. It's probably one of the first things that people start playing around with when they look at what's outside of the course itself that I've taught. They look up for loops and maybe switch statements. You want to get really fiddly with things, you can look at ternary operators as well. I don't use them personally. I think they make everything unreadable, so I don't use them. I use if statements, even if I could get away with ternary operators. So yeah, there's bits and pieces like that that you can use. They're legal, but we don't teach them because they're unnecessary to understand when we're trying to learn the actual concepts. Fishak is saying how to remove decimal while using pow in an array. I'm not sure what you're asking there. That seems to be a very big question with lots of different parts in it. You may have to rephrase that. I'll go on and answer other questions while you're thinking about that one. NK Pro is like, what referencing methods should we use to say we're using similar codes from the questions? I think you can just tell us where you found the thing. So if you put a comment in saying, this came from this location, it's like, I got it from this web page or something like that. I think in general, it probably won't be that big a deal, NK, because the situation that we're going to be in is that you'll only be able to copy paste something if we've written questions that are too easy to do, in a sense. Like they're too easy to search and stuff. So we're usually pretty careful with that, especially when we get to the medium and harder questions where we build examples of things that you need to code about that are a little odd. They're not the standard question of something. So, yeah. But, I mean, if you do manage to get, like, anything more than, like, 2 or 3 lines of code that you're using from elsewhere, please credit it. Yep. Oh, Lewis, you're right. So that was the thing about your own libraries, your own pre-written code. You're welcome. Yes. Okay. I should wrap it up here because we're already 15 minutes over the 2 hours I said I was going on. Vishak, you still have a question that I haven't answered. I apologize, but it looks quite technical, your question, which means I probably don't have time to answer it here. I would say take it to the forums, where you've got more time to actually ask your question, because I think your question looked big, and I think it's something that you might want to type out in more detail on the forums and then ask about methods for doing things there, and then someone will have more time to answer it then. So I'm going to wrap it up here, and just want to say good luck to everyone. I will be around on Saturday, but I'm not going to be like streaming or talking to you or anything like that, right? You're going to be hard at work, and I'll be trying not to distract you. But I will be one of the several people who will be manning that email address and trying to answer all the questions that come in and stuff like that. So hopefully it goes okay. Please don't worry too much. The exam is hard. It has to be hard for us to get an accurate idea of where everyone's up to. So the reason the exam is hard is because I don't want anyone to reach the end of the exam and say, I could have done more. You know, there's more work I could have done. I could have shown that I am good at programming and I can do these things. You know, I could have shown that I understood things. So if I do an easy exam, then everyone's going to reach like the end of the exam before they reach their limit, and I can't assess people unless I can push them to a kind of a limit. So I apologize that I am pushing you to a kind of a limit, because anytime you push anyone to their limit, it obviously causes stress in people, and it could be worse than causing stress. You know, you can really kind of like I don't know what a good word is for it. You can disorient people, in a sense. You can really put people out of sorts by testing them to the limits of their capability. But that's what an exam is, and that's what it must need to be. So hopefully that's you understand that, and then the stress comes from a place where it's testing all the things you've learnt rather than just an unnecessary burden on you. So good luck with everything, and I will, I guess, see you on Saturday to a certain extent. If not, if anyone's keen, I'll be doing something on Monday evenings, actually from now onwards, in a sense, Monday evenings. But like, if anyone wants to come back on the Monday and just kind of de-stress, we're going to go into like much more relaxed streams and less subject-oriented stuff afterwards. Okay, see if there's any other chat. Cactus said, thank you so much for the term. You're welcome, Cactus, and I will see you on Monday. Oh, NK Pro said you're going to miss Chicken a lot. Where is Chicken? Oh, she's not here. Sorry, I can't bring Chicken. She's not here. Oh, Tuaka has an exam on Monday. I apologize. It's not the last time I'll be doing those things anyway. Okay. Alright, I'm going to wrap it up here. Thank you all, and good luck.